We want to define the arc cosine function, the inverse of the cosine function. I don't want to do this for every one of the six trig functions, but I just want to show you that there's a little bit of a difference in some of them because of the way that we have to restrict the domain. So if you take a look at the arc cosine function, you'll see that it would be tempting to do the same thing we did with sine, where we restrict the domain from negative pi over 2 to pi over 2. But look what happens if we try to do that. I'll just put in tick marks at pi over 2 and negative pi over 2. If we draw a horizontal line through the cosine function, we see that on that interval we intersect the graph in two different points. So that choice of restricted domain would fail the horizontal line test. So we can't do that. This is why for the cosine function we restrict the domain in this way. Let me get a thicker line here. We restrict the domain to 0 to pi instead of negative pi over 2 to pi over 2. So we still get a range that has a width of pi, but it's a different set of values. This gives us a graph that satisfies the horizontal line test. So we can use that restricted domain to define the cosine function. So let me just quickly write out the definition of the arc cosine function. So there is the definition of the arc cosine function. That's what it means. And once again, keep in mind that its value is an angle. We measure the angle in radians or perhaps sometimes degrees, but whatever units you want to measure it in, it is an angle. So I've put up here just the definitions of the three most important inverse trig functions: the arcsine, arccosine, and arctangent, and what range the angle comes out to. Notice that arctangent has a range of angles that's very similar to arcsine, but keep in mind that there is no tangent of either pi over 2 or negative pi over 2 because you'd get infinity or undefined. So we have to restrict the set of angles. There's no real number x that would give you an angle of pi over 2 or negative pi over 2. That's why we exclude the endpoints. I put here what the ranges are for the other three trig functions. These functions are defined in the book, and you can look those up if you want. But we certainly make less use of arc secant, arc cosecant, and arc cotangent.